right? So if no, that's now look at the lecture slides on IO exceptions. So exceptions here, well, we especially the exceptions in Java, we mean something that we could control. That's probably your logical errors. Something is wrong with your code that we could control it, that we call it as exception. But it's something that is out of control that you actually break your computer. So that kind of mistakes, we call it as an error. Right? So we want to manage the potential mistakes that we could create. So we want to manage the exceptions. So an exception is an object in Java that we describes it an unusual or unusual scenarios, so erroneous, something that break your code. You use the zero as your numerous you divide it by zero, or you that the user input the integer instead of a strings, or strings instead of an integer, different types of conversions. So whatever the unexpected scenarios that could occur in our code, that we want to pre-plan for those in order to make sure our code, our program will run smoothly. So an exception is defined in an actual package, an actual libraries to describe those scenarios. So when an exception is ignored, your program will yield. Something will print out, on the console to tell you potentially the class not fine, object, the null exceptions, null pointer exceptions, which object are you referring to? So whenever that's not being detected or not being properly handled, your code will be terminated. So that's called, it's an inappropriate terminations of your code. In order to prevent that from happening, so we need to design our code by planning on those potential places that could actually occur the exception. So now here is one example. It's called dividing by zero class. There's only one method, which is our driving class. So we declare everything perfectly, like integer, numerator as 10, denominator as 0, and you print it out the numerator divided by denominator, right? So denominator shouldn't be 0 at all, but that's a legitimate integer variable name, right? So in this case, the error, that mistakes will only happen when you actually execute the code. So in this case, well, it's only because you do the math wrong. It's not because you code the Java wrong. So these potential exceptions, these potential errors should be handled. So you are going to see the output on the console. It actually tells you in the main method, there's arithmetic exceptions by you try to divide it by 0. So something is wrong with that. That's defined in math. It's not because the Java code issue, right? So it's our logical error. It's not because the Java is wrong, but because the math could cause the Java could be wrong. So we still want to handle it, right? So in this case, your output console, we call this is a call stack trace. It indicates the potential exceptions occurred. It's telling you, hey, as a program designer, you should actually handle the potential exception. So when this exception is occurred, we could actually try to stop it to occur, to happen, right? For example, we pre-check the denominator, whether this is greater than 0. Or we actually throw exceptions to tell the user a warning message. Hey, when you have a denominator as 0, you shouldn't do the dividends by that. So the user who try to do the math have a warning to change their mind, to redo the math. So in this case, to prevent, to warn our users potential exceptions could occur, The syntax in Java is called try-catch clause. So here we want to avoid the potential termination of the program that you want to use the try statement. The try is a reserved word. Use the curly braces as the statement. You put whatever the statement of the code to determine if all these statements have something wrong, math, logic, whatever is wrong, I will catch it. Catch it meaning I would detect whatever the errors, exceptions that will happen within this block. And I'm going to tell the user what to do if the actions, the exceptions is caught, right? So what's going to happen is we are going to write the codes within the try statement block. So if there's an exception, we deal with that. We deal with that by telling the users, what are you going to do next? Or you go back to change your input, or you modify something, or simply tell them you cannot do this, right? So dealing with the exceptions, there are a couple ways to do it. Is to warn the user or to tell them the program is not allowed to do that. You have to go back to change whatever the input. Now, there is a catch. After the catch statement, it's called finally. This finally statements, they will always be executed. So, which means, well, I warn you what's not going to happen, but minimally what I would do, what if you want to enforce something to execute it? I already give you the warning, but I'm going to execute the code. These finally statement will come in handy to tell the program designers how are you going to deal with the program. Let me give you one example. When we design the GUI, right? So there is a user interfaces. You could actually pop the user interfaces to tell the user, hey, you actually have an input as an integer 0 that's going to be inside the the numerator denominator. So the math won't check out. In the case, the pop-up message shows you that, give you the warning. You could select, to decline, to accept, to move on. So if you change the input right into the pop-up, then the math could work. If it's not 0 anymore, then you could do the math to do the division. Once the denominator has been changed, you could do the divisions, then the program should work, right? So there's a sequence of the program. Whatever you want to proceed, that try statement, that finally block will allow you to always execute it. Even, the users get to decide, well, there are exceptions, but if you wish to do so, finally will help you to take care of it. So the catch clause will allows you maybe omit it. That means, you could try to detect exceptions, but you don't always have to handle it. If you don't handle it, chances are the program could be terminated, right? Or there are no exceptions at all. But there could be multiple catches as well. Before the finally, you could have a multiple catch. For example, the null pointer exception being caught, or illegal arguments being caught. Multiple different ways of the exceptions could actually compose as a multiple catches clause. So here's another alternative of trying to check a local potential logic. We use try and catch finally statements. But what if this is the entire class methods that could have potential exceptions? That you could throw those exceptions to the header of your method. The syntax looks like this. In the main methods, public static void main. We know this is driver class main method. the main method, what if anything goes wrong within the main method? We just throw the IO exceptions. We treat it as this is the input output. Why? Because the driver class is the entry points. That's the user interface, right? So let me quickly reshare my desktop. So on the right hand side, I'm showing a couple classes from your assignment 6. These are all the given classes. Assignment 6 and department classes are completed. So all you need to code is to build up the generate pane and select pane classes. But assignment 6 is going to be the main driving classes. So what if anything is wrong? This is your UI. So that means this is the entry point the user will be seeing. So we could imagine if there is any user operational mistakes, errors that happen, we call it as the potential input-output exception. So here we want to throw those potential exceptions to the main methods so that we know whatever happens, I don't care what happens within assignment 6. This is within here, we have the start methods and we have the main methods. Whatever happens here in the math, I could throw the exceptions to input output in IO exceptions, which means whatever happens in the UI, I will take care of it and I will print out the necessary messages out of it. Okay, so this is the syntax should look like. Now let's try to put it into the context. Any questions so far? If you scroll down to the slides, you see the example. This is a full complete code. So within this product codes, we only have this driver. This is the driver class because we could recognize it with the main method, right? So main methods, that means everything will execute it as if user were interacting with the program. So now this user input is coming from your console typing in as the input string, right? So we use the system.in as the input string. So we are trying to read what user is typing in. So now the printout is, well, what user will be typing. And every time what we will be checking, it's simply treating this input strings and we see whether there's a next character input. Do you type, just a number or entire sentence? Now, here is a while loop trying to iterate through the entire input stream, treated it as, every single character. If there's a next, I try to deal with it, right? So I try to deal with the code as a strings. All the input I treat it as a strings. And if this strings is more than certain character, if it's not XXX, that means it's not a termination code. If there's a XXX to quit, then I will know I will stop trying to loop. Now, if it's not XXX, then we will iterate through the entire strings of input. Within this input, what we will be doing is put whatever your checked inside the try catch block. The try statement here, what we do is assign the number 9 character to a character called zone, right? So this is actually a legitimate line of Java code. But what if our input is shorter than 9 characters, right? What if you just type in as super, right? There are only 5 characters. You don't even have 9, right? So in this way, you are actually trying to potentially impose that out of bound exception, right? So if you type in a longer sentence, that's fine. You could get the number 9. But what if you type in a shorter sentence, less than 9 character? then this string could have an index is not being pointed to the right place. So that's why we try to catch potential string index out of bound exception. So the way to use it is, well, we want to assign number 9 character to a character variable, fine. But what if the sentence is shorter than 9? Then let's just catch it. This is not enough length, right? So this is an improper input length. Now, potential other mistakes could be like, well, once we get a substring from the code, for example, in this case, we try to get the substring from number 3, index 3 to index 7 character. And then we try to parse them into integer. But what if the input is actually a sequence of strings, right? All the letters, then you couldn't parse all those letters into integer. Then this will be a potential number format exception. So there are multiple places, each line of code, there could be potential mistakes that we want to catch it. What if this is more than what we know? Then we could simply catch it as generic exception, code it as the exception, right? So the potential exception places that could be here and there. Then how do we know which class that we are going to use those exceptions in order to catch them, right? So this will actually come from the API library. So you need to study a little bit. But what I'm going to point it out here in the slides, these two minimally that you need to know. Potentially, we make the mistakes that we think that, well, we always want a number 9, but chances are you could have a different sizes of length of the input. So potential index out of bound exception is a very common mistake that it could make. The other one is number format that we could make those errors. So these are the popular exceptions class that we need to know. But there are more than these two. In your slides number 5, you can look into the throwable interface. There are 2 of them, arrow classes and exception classes. And whatever the classes that inherit from and implement the throwable interface and inherits from exception class. IO exceptions would be the common class. Class not found exceptions is also another common class. Class not supported exceptions. And the rest of those fall into the categories we don't know. They only happens when the wrong times, when your Java is actually running the codes, then we will find out. And those are common exceptions. One of them is index out of bound. We just see that. And the other one is null pointer exceptions. We don't know which object you are referring to, right? Illegal arguments. These are all common exceptions, right? So which one should we use? That it will kind of relies on the experience, but minimally that all those exceptions that we have seen in class, in UI, that will appear in your exam. I won't just randomly, give you whatever the names that you have never seen. But in the example here, at least we see 2. This 2, you should learn how to use it and be familiar with all these 2 classes. Now, coming back to the slides number 4, there potentially have the UI exceptions, class not found exceptions, null pointer exceptions during the runtime. So we categorize these 2 into 2 categories, checked and unchecked exception. Check exception meaning we could actually try to manage it by try and catch block, or we could actually use the throws to identify which methods that actually have the errors, right? So now you could kind of think about, there are 2 ways to catch exception. One is to use the throws by attaching that throw exception class after the method's definition. So you could see the potential errors could go inside the entire method. The other one is to use the try catch to localize the potential errors that could happen, right? So there are two ways to use it. You could use both way in the same methods too, but those are the potential strategies to help you design your codes, especially during the development process. You are going to rely on localizing methods such as try and catch a whole lot more. But once the program's developed a little more mature, you want to utilize the larger scales such as the throw exceptions to the methods in order to organize the exceptions through method definitions. Because the methods, we typically write the documents about that. So you could have the documents to help you understand why those exceptions are making those errors. Now, coming back to this slides number 4, those methods that we could manage, we call it checked exceptions. But if those are the unchecked exceptions, how do we handle it, right? So that should still be try to, managed and try to be caught. So unchecked exceptions that could happen in the Java, such as the runtime, right? We don't know until it actually happened, right? So we actually define such a class called runtime exception. So whatever we don't know before we execute the codes, chances are they are the runtime exception. For example, if you naively implement the codes of the math trying to use whatever the first number divided by the second number, but without checking the second number could be 0, right? But you realize it during the runtime. When you execute the code during the runtime, the call stack trace, which is your output console, will print it out the red text, tell you, hey, this program is being terminated by dividing 0. So this way that you could actually try to catch those runtime exceptions into throw the runtime exceptions so that we manage all those errors, whatever next time the second input, second number, if it's a 0, at least we know that there is a 0 being input, the exception is taken care of. So the point being, whatever the exceptions that we could manage, we should program them during the localized try and catch block or organize it onto the entire program methods levels to throw those exceptions. But if you run your codes, you see those exceptions, they appear, chances are that's runtime exception. Those are unchecked exception. Once they are detected after you already run the program, you should come back to redesign your program to handle those runtime exceptions, okay? So the differences from the throws and try and catch is, one is you trying to pinpoint which line of a code could potentially have the exception, right? So if you throw the exception, the method will still be executed. But instead of terminating the entire program, these exception, string index out of bound, if you throw it to the methods, that you will still see the output printed out to tell you there is a string index out of bound exceptions that's being called, but the program will not be terminated. All right. At this point, I would like to switch to, please download these two classes and import it to your. So this is now you should be able to see my Eclipse. On Monday, the event practice 1 that we run the program, we generate this UI. So we have a label, we have a 4 check boxes, and we have 2 buttons and 1 text area. So once we check the buttons that we check those items that we wish to buy, we click on the checkout. Then we say, hey, you know, I just print out 2 items that I purchased. And if we click on the reset buttons, and apparently I did not finish implementing my code. So it's supposed to remove, let's see. It's supposed to remove the selections from the checkboxes and clear out the entire message from the text area. So now, if you run your event practice 2, I slightly change it. Is we no longer hard-coded it of 4 items of checkboxes, right? We could allow the users to build, hey, what in your store, what products that you are going to sell, right? So once you create all this product, then you could allow customers to actually try to purchase those products, right? So for example, now I change it to 2 labels, 2 input boxes, 3 buttons. And the first one is for the users to create, for the store owner to actually create a product. For example, we could still call, you know, hey, let's still sell some coffees. Each one of the 1 cup of coffee is $2. So you could see, once I create this item, there is a checkbox being created, right? So I could sell cream. Okay, I'm even charging you a cream for 50 cents, right? So, well, we could sell a banana, I don't know, for $10, right? So now I could start checking out. I want to buy the coffee and a cream, and the total price would be $2.50. Combine these 2 items, and if I don't want to buy this anymore, let's reset from beginning. Oh, apparently I only reset these. I did not reset all those inputs. You could modify the codes, whatever you want, right? But you get the idea. Is I slightly change the code without hard coding it. Now, this is what the entire program would do. Terminate the program. Let's look at the code. So in your assignment 6, what you are going to do is practice a little bit of this. This is called code reading, and try to understand it, how those codes are doing for you, and how do you build on top of the code, okay? So let me collapse. We create this event practice 2 extends from JavaFX application. So that means we are creating JavaFX application. So we still have a checkout button, reset button, and we have a checkbox list, message area. This is all the same as your event practice 1. But there are new elements that I created onto this GUI. For example, I have 2 labels. One is for owners to prompt them, hey, what products you are going to carry, right? The product name, the product price, and the actual input area as the text field, the product name, the product price, okay? And another button, it's simply create a product. So you could imagine when I click on that create a product, I associated create a new checkbox item, so that I'm not hard coding it to a new instance variable, an attribute for the UI, right? So the attributes supposed to grow and shrink whatever I want to carry for my store, right? So this way is how you manage it. If you want to manage your checkbox, you need to create the corresponding checkbox list where you store all the product and where you store all the checkboxes object into that array list. So these are sort of the new UI elements. Now, scroll down, the main method stays the same. The main method is because this is the driver class. We will inherit from the Java FX, we should override the launch. They will call the start methods, whatever the arguments that you have in this driver class. So we push it when every time you are executing this program, run it as Java application, we will actually treat it as starting Java FX application. Okay, so this is a must-have methods. Now, the override the start methods, this is all the same, but I throw the exceptions right here. I could have throw the IO exceptions as well. So now you see the IO exceptions. That means I need to import input-output exceptions to this particular method class. So whatever the errors happens in the UI, tell me on the console. I need to know so I could go fix it. Now, if you scroll down, the layout looks very similar, and I only noted it here. There's an event practice 2, which is the new layout. Because we want to initialize, well, what's the label should look like on the UI, and actually created a text field object so that we could know whenever user create a new product, banana or the coffee, that I would know which product that you are talking about. So once the product name, product price has been created, obviously, this is what I imagine, a very simple attributes to design a product. So look at the product class. It's very simple. I only have 2 attributes. Whenever you have a product name, product price, I think this will be something a very, simulated store will be able to carry it. But in reality, you are actually trying to one step closer to build the databases, right? So you are thinking that, hey, when I create a product class, I should probably have the product ID, right? So that I don't have a duplicate coffee, or I could treat, coffee based on their coffee names, right, as a totally distinct product, right? So not because the product name and price combine as a generic product, right? So you should define whatever the attributes within these product object. So here I'm only setting, if you have a product name, product price, then I create such product object. Now within the product object, whenever you click on the create product button, once this button is being clicked, I am going to set it on action of a new event handler. So Monday, I talk about it. We could create a button handler, a new inner class to handle this event. Or I could create an anonymous inner class in order to do that, right? So whatever the methods that you use, make sure that this is we are implementing the event handler interface. We are actually creating this methods by attaching, overriding actual implementations for this interface method. So within this interface, there's only one method you have to override it. That's called public void handle methods. The handle methods will handle the action event, which is why we use every button you invoke the set on action. Set on action, meaning when you click on the button, we set something on action. Even you just, drag it, the button, you mouse over this button, I will treat it, something happened to this button. So whatever the actions happening to the button set on action, I will implement the handle methods with the action event. So if the event is the buttons being clicked, I'm going to do something with that. So in this case, I built in the try and catch block to see whether you have the products that's typed in. If the in text field actually have a text So I could try to create a product, right? But what if the text field is empty? I couldn't really create a product, right? So for example, here, the catch, I only attach a generic exception class. So whatever happens to exception class, I am going to throw it, hey, print it out, let me know what is wrong with that. All right. Do I see anywhere I have a problem with the code? I don't think so. Okay. So now you could try to run the program. So if I have banana, apparently I really like banana, huh? Create a banana. But now if I remove the input text and try to create a product, see, there's an empty thing, empty string that's being created. So this is supposed to be an empty product that I shouldn't allow me to do this, right? So once there's an empty string, we technically should handle this error, right? So this will be a potential exceptions that we should be dealing with. So you should come back to the codes that we should deal with if this is empty, then we should catch the exceptions, right? So we could modify our codes to make it not allowed to strongly enforce the text field product name and also the product price has to be products, not empty strings. So this way that we could enforce our codes will be complete. All right, so this is just a mini exercise. I want you to try to read my code at home and see whether you could understand the entire interactions.